might be surprised you will find no slides. The benefit is you need to listen and look at me. The disadvantage is you might not capture all what I'm saying, but there's a video taking, so you should be able to see it. A lot was said before, and I want to give you another few numbers and a little bit of a picture. The world is hungry for concrete. We build every single day. And if you sum up all the construction activities of the world, then the world is building Paris every second week. Or New York once a month. That means we build every year 12 times New York. Every single year. That's not going to change. Construction happens worldwide. More in Asia and Africa, yes. We heard before. Infrastructure, affordable housing, that's something which is going to happen there. Still in Central Europe, there's a need of concrete and cement. I'm leading a cement company in Central Europe, Austria, and in Austria, every single year we pour and use 15 million cubic meters of concrete. Every single year. It's from Monday till Sunday. And we had now half an hour. With this half an hour worldwide, the cement industry was emitting some 120,000 tons of CO2 just in the last 30 minutes. We also call it the hard-to-abate industry. That means our technical way how we produce cement requires to kind of cut off the CO2 from the natural limestone. That is a challenge that leads to a lot of CO2 emissions, and you know the numbers. If you sum up the CO2 emissions of the cement industry worldwide, you would turn it into a country, would be the third biggest CO2 emitter worldwide. That also gives a lot of responsibility to the industry. And when we talk about CO2 removal, the first question is how can we limit the emission of CO2? Christian mentioned I had various functions in the company I'm working for. I'm a finance guy, so I'm not a technician. If you have technical questions, I'd be not the right one to answer. But I've been leading one of our cement plants as the first non-technician leading a cement plant. But still, I understood what is needed means when my company, Holcim, is talking about net zero by 2040. And if we in Austria, Holcim Austria, talk about net zero 2030, wow, that's a challenge. It's like flying to the moon. Yeah? In the 60s, when John F. Kennedy said, let's land the man on the moon, the people said, oh, the guy's crazy. It's technically impossible, but why? If the US manages, that's great. That's what we at Holcim start. We want to change ourselves to a level that people and society says, technically at the moment, how to do that. But if they manage, they will be the first mover. The first is, for the next years, we will not have a carbon capture in Austria. We will not have a lot of carbon capture installations in Europe. I mean, there have been some fundings approved, but the factories will not be there. That means we will have to have a strong focus on using circular economy. That's the first. We start using material which is available. Construction demolition waste, byproducts from industries, that's where we have been strong in the last years. Only at Holcim in Retzen, that's our smallest cement plant, we use 40% of not natural limestone. So our alternative raw material ratio is at 40%. At 358 days a year, we don't use primary fossil fuels. We're running on substitution fuels. That means we do a little bit already to reduce the CO2 emission. Still, if you look to the numbers and our official reports, we emit 650, 630 kilogram CO2 per ton of clinker, still too much. So the second biggest lever is CK ratio, to get down with the energy intensive material in the cement. You reduce the amount what you put in, and was mentioned in today morning, the morning session. In Austria we have started to introduce a CEM2C, a cement with only 50% cement clinker inside, which for the main applications works pretty fine. As mentioned before, building a bridge, no, for this we have very good and special cements, cement for the tunnels, but for the main application, that's going to work. And that reduces the CO2 per cubic meter of concrete. I'm reflecting now to the speech before, to below 200 kilograms, but 100, 150 kilograms, 120 kilograms CO2 per cubic meter of concrete. That means a big lever is there in the formulation of the cements we do. So, what to do with 650 kilograms or 600 kilograms of CO2? Carbon capture. Carbon capture is, for the hard-to-abate industry like cement, the only way to get to a zero. There's no other way at the moment. We cannot produce cement at the end of the day, concrete, not using cement. It's not possible. It doesn't work. It doesn't get hard. Even if it gets hard, it's not lasting. So, the world we're living in a concrete world. The living standard we're used to is built and based on concrete. So the big challenge for the cement industry is to further be more a solution provider, and at the same time, as we might be perceived as the problem bringer with the CO2 emission and contributing to the climate change, means we need to take it serious when it comes to carbon removal or to carbon capture. Carbon capture is not cheap. Was mentioned 600 euro per ton for removal. If we talk about carbon capture technology for our biggest cement plant in Austria, Mannesdorf, we can emit per year 750 to 800,000 tons of CO2. We're talking about €500 million investment. It's almost impossible to finance. Also very tough to finance because we're not talking about a payback of 3 years, 4 years, 5 years, or 10 years. We're talking about more than 10 years, 20 years, 30 years, perhaps even longer cycles. That also requires a different way of financing instruments. On the normal finance markets, this will be tough to get 500 million financed for 40 years, 50 years. But there have been solutions available already. Just think about the Marshall Plan after the Second World War to rebuild Europe. It wasn't done within 2 years, and the payback was also not 5 years or 6 years. It took much longer. So it means we need different financing instruments. If you talk about the carbon capture, the question is, what do we do with the carbon afterwards? There's two technologies, and one of them is explain a little later, because we're working on that. At the moment, in the European Union, for the cement industry, carbon capture storage is at the moment the only way that's going to work because of the way how the CO2 is seen, what we emit. CO2 from limestone is seen as fossil, so we need to remove the CO2, and that means carbon capture storage. We have the first carbon capture storage which goes live, Breivik, Norway, which is working. There are carbon capture facilities worldwide in Canada, they're working, existing. But at the same time, if we talk about carbon capture and we store it in the underground, we heard the nice examples, carbon is valuable. We are here because we have carbon. I mean, you know, the body consists out of 70% water. And if you split it into the atoms, you have 65% oxygen, and what a surprise, second in place, it's carbon. So what gives us life at the same time is in the combination of CO2, life endangering. So the best way is we start to use the carbon out of CO2. And the technology, carbon capture utilization, is available in there. We have started in Austria a few years ago a project called C2PET, Carbon to Product Austria, where we together with oil and gas in Austria and plastics in Austria have developed a model, and we have been working for some time on that, how to utilize the CO2 emitted by the hard-to-abate industry, cement industry, and to turn it finally to make it very short into plastics or into fuels. It would save gas and oil from the primary source, so it can help. There are two challenges. The first one is still the regulation, because at the moment, using the CO2 out of our cement kilns to use for utilization is not excluded from the ETS, so we have the legal topic. The second is its cost and energy. We did a calculation for our cement plant in Wandersdorf with 750 to 800,000 tons of CO2. Carbon capture utilization would need electricity 8 to 10% Austria is using at the moment. That's huge. And we're talking about more than 1 billion of investment. That's even bigger than carbon capture storage. So that means short term, we need to work on reducing the CO2 emission at the stack. Mid-term, carbon capture storage might be the only way to start. And there, that's my last remark, carbon capture storage at the moment is mainly done offshore. If you look to the projects which have been approved also in Europe, majority of them store offshore. They go, let's say, out to the sea and sink it there. We have 2 cases now in Europe where onshore, inside the country, storage is possible. For Central European countries like Austria, Switzerland, Czech Republic, Hungary, offshore is very expensive. And if we need to rely on an offshore solution, then we might not get the funding because we will always be the most expensive solution. So we need an onshore solution, which is again a message to us all as a society and politicians that we need to make sure that locally storing of CO2 is possible. Speaking for Austria, it's good to know that the old government in Austria has been working on that, and it looks like that it's going to happen. So for the cement industry, it's important to have clarity about the future. As I mentioned before, we are going to invest into something which should last for 50 years. That means we need to have security where we're going to. CO2 and carbon at the same time giving life, at the same time endangering. It's the hunger of the world for concrete. It means that's one of the megatrends. We're not going to change that. And that again means how can the cement industry become the solution provider? And I like also the message. The more concrete we use, the better it is to sink. I mean, I'm not here to sell more cement and concrete, but I think we need to do the right thing. And doing the right thing means we also need to talk. We need to be clear about what is important. And the cement industry is here, it's ready to invest. We need clarity. And for that, I leave the floor for questions. Thank you very much.